So this is 6.1 Introduction to Derivatives. Before we start, it is important to note some important vocabulary. Starting with tangent to a curve, which is a line that only touches one point on the graph locally, which is demonstrated by this graph here. And then our next vocab word is gradient of a function at point P, which is the gradient or slope of the tangent line at point P, which is normally a number. Then we have slope of a function, which is a function that describes the gradient of the original function at any point. Next we have discontinuity, a function whose graph requires the pencil to be lifted due to there being at least one point when the graph is undefined. We have three different types. We have jump discontinuity, where it's on completely different parts on the graph. Point discontinuity, where it's a curve that is interrupted by a circle or a point that is undefined. And then we have infinite discontinuity, where there are two different curves that never touch. And then we have continuous function, which is a function whose graph is a smooth curve and is always connected. Then we have limit, which is the value of the value which a function approaches. So this is demonstrated by lim f of x, and then it says x of a, which is the limit as x approaches a of the function f of x. Next we have derivative, which is a function whose y value is the gradient of the original function. The original function is increasing when the derivative is positive, and the original function decreases when the derivative is negative. And we have some more vocab, which includes differentiation from first principles, which is the derivative is the gradient as h is getting smaller, and here's the equation for that. The first derivative of x is equal to the limit as h approaches 0, function x plus h minus f of x divided by h. Then we have tangent line, which is a line that only touches one point on the graph locally. And we have normal line, which is a line perpendicular to a tangent line. This is all demonstrated by our graph over here that has the curve and then the normal and tangent line. As you can see, the normal line does create a perpendicular line to the tangent line. And next we have our first example, which is find the derivative of each function and simplify. So it's important to note that we're going to be using the differentiation from first principles equation. So our equation that we're going to be solving is f of x is equal to 4x cubed minus 3x squared plus 2x minus pi. So we're going to plug this in to our equation for differentiation from first principles, and you're going to have 4 parentheses x plus h cubed minus 3 parentheses x plus h squared plus 2 parentheses x plus h minus pi, and then you're just going to write down the original f of x function, and then you're going to expand all of that, and then you're going to get 4x cubed plus 12x h plus 4h cubed minus 3x squared plus x plus h plus 3h squared plus 2x plus 2h minus pi minus 4x cubed minus 3x squared plus 2x minus pi. And now that we have this whole equation, we can simplify this on top. So we can combine like terms, and so we're going to be left with 12xh plus 4h cubed plus 6h plus 3h squared plus 2h. That's supposed to be squared up there. 12xh squared. And then we are going to try and get h by itself, or factorize it. So what I did is I took an h out, and then I got 12x plus 4h squared plus 3h plus 2 plus 6x. And there's an h in front of it, and you divide by h, and these h's can cancel out. Then we are left with the limit of h approaches 0. We have 12 x squared plus 4h squared plus 3h plus 2 minus 6x. And then we're going to plug in 0 for h, and then we are left with 12x squared minus 6x plus 2. And that is going to be your first derivative. And now for the second example, we're going to use the graph of the function f of x to estimate the value of the first derivative of the given value a, and we are given the values. So here's our graph, and our first point is a is equal to 1. So looking at when x is a, it looks like it's about -4. And what we're going to do is sketch the tangent, which I did, and then step 2 is function is decreasing, so the derivative is positive. So f of 1 is equal to 1. And now for our second one, a is equal to 4. And once again, function is decreasing and derivative is going to be positive. So we have our first derivative of 4 is equal to 5. And now for extra practice outside of this video, I looked at page 358, number 2, and what you're going to do is prove that the first principles that the derivative of x squared plus 1 is 2x, and that is going to be 4 marks. And your second problem is going to be on page 375, number 2, which is find the equation of the normal to the curve y is equal to 3 minus 1/5 e to the power of x at x is equal to 2 log natural of 5, which is 7 marks. I'll give you some time to write this down. And here are your answers. For the first one, here is all the work that you will probably need to write down. And then here is the final answer to the second problem.